Hello and welcome to our training titled Linux Directory Mastery for Cybersecurity Experts. It's really important for cybersecurity experts to know about Linux directories because a lot of cybersecurity tools that we work on are Linux based, and Linux forms a major part of our digital infrastructure, and a lot of our efforts would go into protecting the Linux environments. And we will talk about some more reasons which make the Linux directory structure important for cybersecurity professionals in the next slides. We will learn about Linux directories in this video by comparing them with Windows directories because most of us already know how to find files in Windows. So we will use that knowledge to understand Linux better. So in each part of the training with each slide, we will look at a Linux directory and then try to understand what is the equivalent directory in Windows. Sometimes we may not find an exact match for the Linux directory in the Windows, but that's okay. The main idea is to make Linux easier to understand by using what we already know from Windows. So Windows has been our go-to operating system for decades, familiar for its widespread use and graphical interface, security incident investigation, malware hunting, threat hunting is more intuitive for cybersecurity professionals on Windows. It's a lot easier on Windows due to its graphical user interface nature. However, in the world of cybersecurity, Linux holds a crucial role. Many powerful cybersecurity tools, including Kali Linux for vulnerability assessment and penetration testing. So Kali Linux is also termed as Hackers OS, which has a comprehensive suite of security tools. They are all Linux based. A lot of SIEM systems are Linux based, like Splunk is built on the Linux kernel and are fundamental in our field. So this makes an in-depth understanding of the Linux environment for cybersecurity professionals an essential skill. By becoming proficient in both Windows and in Linux, we will enhance our ability to protect and secure our digital environments effectively. Around the world, Linux is everywhere. And to start, Linux dominates the server market, whether we are talking about web servers, databases, or application servers. Linux is the backbone for a vast majority of them. For cybersecurity professionals, this translates to a simple fact: a major portion of our protection efforts is directed towards environments running on Linux. Beyond traditional servers, Linux also powers most of the world's supercomputers, making it pivotal in research and high performance computing domains. Moreover, the flexibility of Linux has made it the go to choice for numerous IoT devices. And let's not forget mobile devices. Android, the world's most popular mobile operating system, is built upon the Linux kernel. Many of the network devices, they operate on a Linux based operating system. Many routers and switches, for example Cisco's iOS is Unix like, and many other network devices also from other vendors run on Linux based or Unix like systems. Many storage devices from different vendors, they run on Linux based or Unix like operating systems. And having a familiarity with Linux directory structure, just like we have for Windows, will make it very easy for us to work with these network devices as well. So in summary, then all these devices and operating systems are either directly based on Linux or inspired by Unix and share the same directory structure. They share a lot of commonality. So being aware of Linux isn't about broadening our knowledge, it's about being equipped to secure a world that's increasingly powered by it. And as we will discover in this training, understanding its directory structure is the foundational step in that direction. So let's get started then. We will start with the main, um, you know, root directory. So the root directory that I'm showing you here on the screen, this is symbolized here as the base of our tree. The root is a crucial, it's the starting point of all other directories in Linux. So from this main root directory, you will have 17 main branches that extend, representing the key directories of a Linux system. You don't need to by heart all these directories, but I promise you, as you go through these videos and as we dive into the explanation of each directory and start comparing them with Windows, you will kind of automatically memorize these directories, these 17 key directories. So let's start with the first directory, that is the root. The root is the absolute base of the Linux file system. So the whole file system of Linux, it starts from this root directory. Every single file and directory starts from this root, making it the starting point of the entire file tree system. And what is the equivalent for this root in Windows? If we have to draw a comparative analysis to understand, C drive. So typically in most Windows installations, the C drive is where the operating system is installed. It serves as the starting point for navigating the Windows file system, housing system files, install programs, and user data. Just like we have 17 main directories that I was showing you on the previous slide under this root directory, in the same way, this C drive has lot of subdirectories under it. So the C drive here in Windows can be said to be the root of the file system of Windows. Let's move on to next directory, /root. Now this /root is very different from the root that we were discussing on the previous slide. Root is the administrative user in Linux, just like you have administrator in Windows. In the same way, in Linux language, for the administrator account, you call it the root account. And this /root, this slash is the main root directory, and that under that you have this subdirectory known as root. So this is /root. So this is the administrator's home directory. So all the administrator's file, his personal settings, configuration, they are all stored here under the /root directory. If we have to understand this more by comparing it with Windows, we would say that C user /administrator. This is the equivalent directory, that can be said to be equal to the /root that we have in Linux. The context in which these directories are used differs between the two operating systems due to differences in user account management and security practices. In Linux, it's common and often recommended for administrative tasks to be performed using a regular user account with the ability to elevate privileges via sudo. So sudo is the command using which you can elevate your privileges while you are logged in as a normal user account. In Windows, it is also possible to log in directly as the administrator. It is more common for users to operate under less privileged user accounts and use administrative privileges only when necessary. So, but in Windows, the administrator's directory is not separated and isolated the way you see it in Linux. In Windows, it's simply under the user's directory. But in Linux, it's under this main root directory. And the user's directory, we will discuss this on the next slide. /home is equivalent to the user's directory that we see in Windows. So it is structured to accommodate multiple users on a single system. It is used for storing user data. It is used for storing personal configuration files of the user, documentation storage, isolation and security. Each user has his own directory and which is isolated and secured by appropriate permissions. But here you will not find the administrator's directory, because slash root was the administrator's directory that we saw on the previous slide, which is directly under this root directory. It is not under slash home slash the way we saw it in Windows. So in Windows, you usually see this C slash users and then username. So the concept is very similar. The C users directory is for different users, multiple users who would be using the system. They will all have their own directory to store their personal files, personal configuration and app data. And so Windows and Linux here, they share the same philosophy when it comes to managing user specific data, but the only difference is that under slash home you will not find the administrator user, the root users directory. You would find it separated, isolated from other users, whereas in Windows you would find the administrators directory under the users subdirectory. Then let's talk about slash bin. Bin stands for binaries, and this is a subdirectory of this root, which contains all the executable programs which are used for minimal functionality for booting or repairing. So the basic idea is that Linux separates system tools into different directories based on their importance and when they are needed. So slash bin, and then which stands for binaries, and slash sbin, which stands for system binaries, they contain critical tools that are needed at the very start of the system, or they are used during system repair. And we also have slash bin and slash sbin under slash usr directory. We will talk about that on the next slides. But yeah, so here you can understand that the slash bin and slash sbin, which are directly under the root, under this root directory, they contain very important tools that are needed to fix or recover your system if there are problems. They are not used every day, but only during when problems occur. So these tools are necessary even if only the basic part of your system is working. Some of the scripts, some of the executables that you will find under slash bin are also ls and cp. So ls is to list the files, cp is to copy files from one place to another. So you will find those scripts under slash bin. What is the equivalent directory for this in Windows? So in Windows, this is perhaps the most direct counterpart, System32 and Windows. So System32 and Windows, they both contain many of the executables and command line tools that are vital to the operating system's functionality. The Windows, this directory also includes important system executables and utilities, but it isn't as specialized as System32. One major difference here is that the way bin and sbin are also exist under slash usr, here there is no such bifurcation. I mean, under System32 and Windows you will have it all packed together. So the Windows file system is not as expanded or as separated into subdirectories as Linux is. So you would find System32 and Windows a common counterpart to a lot of directories that exist on the Linux side. Then sbin, as we talked about binaries on the previous slide, they are essential for day-to-day operations. In the same way, sbin, this directory contains system-related binaries. So these are essential commands that are generally used for system administration, and they are used by the root user, and a normal regular non-privileged user will not have access to this sbin directory, and during some specialized repair and maintenance, where you would need some kind of these tools to troubleshoot the system related issues like check and repair disk or maybe to shut down the systems. All these are executed from the sbin directory, and all these scripts are stored in the sbin directory. In Windows, as I said on the earlier slide, that Windows is more uh, tightly packed, and it is not its file system is not as expanded and separated into subdirectories as Linux. So System32 is the most equivalent directory for sbin, which contains the important scripts essential for system maintenance and troubleshooting. So like sbin in Linux, many executables in System32 they require elevated privileges. However, it's important to know that Windows doesn't segregate system and administrative binaries as distinctly as Linux does with its separate bin and sbin directories. The System32 directory in Windows serves a broader purpose, encompassing both system critical executables and the administrative tools together. All those are placed in the same directory. /usr, this is one of the biggest directory which you have under root in on the Linux side. It's a central location for installing and storing user space programs and data. Standard applications like the user bin directory contains most of the user executable programs. So it would contain tools and programs that are needed for day-to-day activities, which are not essential for basic system repairs but important for regular use. For example, browsers, word processors, games. You would find all these which are required in day to day by the users stored under /user/bin. The previous /bin that we were talking about, it will not have these day to day activities. It will have only very I would say basic executables which are required for the system to run, like most of the common commands that we were talking about on the previous slide. Copy, list, all those executables are there. And then in terms of system repair and emergencies, you need those binaries from the /bin. But /usr/bin, this contains the day-to-day programs like browsers, word processors, games. Then you have /usr/sbin. This is also part of /usr directory. Similar to the sbin that we saw under root on the previous slide, here the tools are needed for emergency repairs used for routine administrative tasks. Example, network setting tools. So think of bin and sbin that we were seeing on the previous slide as the emergency toolkit for the system, and think of this /usr bin and /usr sbin. These are more like everyday toolkit which are needed for regular and administrative use. So for the regular and administrative use, whatever scripts, executables you need on Linux by the system admin, they are stored under /usr sbin and /usr/bin. In Windows, program files x86, System32, resources, there is no direct equivalent to /usr. However, elements of /usr can be compared to various Windows directories. So for example, executable programs, Windows stores most of its executable programs under x86 and program files directories. System and administrative tools, they are stored under System32 directory. DLL files, dynamic link library files, they are stored under System32 alongside the applications that you have installed in program files. Shared resources like icons, images, they can be found in various places, including the cwindows/resources directory. User programs installed by the user which are not part of Windows are typically located in sys program files. So the structure of /usr in Linux is more unified and standardized across different distributions, while Windows categorizes similar types of files and programs across different directories, often based on their function or the application they belong to. Okay, /boot. This is pretty easy one. /boot, it will contain all the essential files that are needed by your system to boot up. That's it. In Windows, you would have, especially there's a hidden partition starting from Windows 7 known as system reserved partition. This will contain all the boot configuration data, bootloader that is needed for booting your system. Also, there are some boot files that are available that are utilized from the system 32 and this C Windows boot directory as well. So in summary, the boot process and related file storage in Windows are somewhat less centralized than in Linux, with critical boot files distributed across a system partition and within certain system directories. Then we have /dev, the next directory. What it is, the /dev directory in Linux, it is where your computer devices are listed. So in Linux, there is a saying that everything is a file, and yes, instead of regular file, it will contain special files that represent your devices that are connected to your laptop. So these devices can be things you have physically connected to your computer, like USB drives, CD drives, or hard drives, and also some internal parts of the computer, like the hard drive inside your computer, or even virtual devices that the system uses. How it's used: when the system or a program needs to talk to these devices, like reading data from a USB drive or sending data to a printer, it will use these special files that are listed under /dev. Does a regular user need to interact with the files that are under /dev? No, they don't need to interact with them. The system handles these interactions behind the scenes. So for instance, when you plug in a USB drive, your computer automatically takes care of the details using /dev. If you connect a USB drive, the system will create a file under /dev, something like /dev/sdb, and this file is the system's way of acknowledging that it has recognized the USB and it has mounted it. And then you will access the data from that USB drive by going to a /media directory, which we will discuss on the next few slides. So think of dev as a control panel where every device that is connected to your computer gets a switch or a label. The system uses this panel to manage and communicate with all these devices. You as a user usually interact with these devices in a more user-friendly way through other parts of the system, not directly through this /dev directory. So this /dev directory is specially used by the system for its own interactions, and only during troubleshooting the system admins would go into these directories. What is the equivalent for this on the Windows side? Device manager and registry. So device manager on the Windows side, it is represented as a graphical interface where users can view and manage hardware devices that are connected to the system. It provides a way to access the properties and configurations of various devices, similar to how /dev in Linux lists these device files. System registry will also contain some information about the devices that are connected. So unlike Linux, where device files are represented as file entries within the /dev directory, Windows handles devices in a more abstracted manner, primarily through the device manager and system API calls. The concept of interacting with devices as if they were files, which is a very unique philosophy of Unix and Linux, it is not natively mirrored within Windows. So Windows will use a different way. So in device manager and registry, a user can also access them, but usually behind the scenes, Windows is using API calls, WMI queries to interact with these devices. So that's about the /dev directory. Then you have /sys directory. The /sys directory is also an information center about all the devices that are connected to your computer and certain parts of the computer itself. But don't confuse it with the /dev. They both have very different purpose. The purpose of /sys is to provide detailed information about the system's hardware and some of its settings. Unlike slash dev, which is more about representing the devices for use, slash sys is about understanding them and tweaking how they work. Types of information in sys, you will find lots of different folders and files. Each of these represent different parts of your computer's hardware, like USB ports, network adapters, or even the CPU. Usage, it is often used by system administrators and advanced users who need to get detailed information about the hardware, or they need to change some low level settings. For example, you might find details about how much power a USB device is using, or you want to change some settings, you want to fetch the serial number of a USB pen drive, then you would use that. So example, say you plug in a USB drive along with the slash dev entry that the system uses to interact with the drive. There will also be entries in slash sys. These entries will provide detailed info about the USB drive, like what kind of device it is, its manufacturer, and other technical details. So on the Windows side, you can understand, like under device manager, if you go to properties and under device manager, everything is listed there itself. But Linux, on the other hand, has this separation and isolation into several subdirectories, where it is, you know, spreading out this information, distributing this information. So think of slash sys as the behind the scenes encyclopedia. It's where the system keeps the detailed information and settings of all the hardware pieces. As regular users, you don't usually need to interact with it, but it's invaluable for troubleshooting, system administration, and understanding your hardware, how it is set up and how it is functioning. Only in terms of very, I would say, as cybersecurity professionals also, you will not need to interact with this directory a lot. Yeah, I mean, for getting information, for understanding how the hardware is set up on a server or a endpoint or a Linux endpoint and its functioning, you will access, but not a go-to directory at the very first for security incident investigation. As I said, that on the Windows side, device manager will allow you to view and interact with the hardware and drivers. It will provide functionality somewhat similar to what you can find in slash sys, but through a user interface rather than a file system structure. So Windows uses the registry to store configuration and operational parameters. It's somewhat analogous to slash sys. Then you also have system32 directory, which will have some low level system files and drivers stored in it, but it doesn't provide the same structured view or direct interaction capabilities as slash sys. Because Windows and Linux, they both are designed differently. Like Windows is a closed architecture operating system. Even if you are a full super admin on a Windows server or a Windows workstation, you still do not have the liberty to play with the operating system or customize it or redesign it the way you have on Linux, because Linux is open source on this. If you are a root user, if you are an administrator, then you have full permission to view all the files, change, customize, redesign Linux. Then slash etc, whenever you think of configuration files related to system, like, think of slash etc. On the Windows side also, you have slash etc under system32, where you will find the host file. A lot of you might have worked on the host file for creating a ad hoc DNS entry, or deleting some DNS entry, playing with the host file. In the same way, the host file is also found under slash etc in Linux. So also, IP configuration related settings, if you want to change the IP address of the system, either you can do it through a tool, or either you can do it through accessing a specific file under slash etc for the IP address. So all the configuration related information which is needed for administration purpose of a Linux server that is found under /etc. On the Windows side, registry, system32, program data, these three directories will store all the configuration file for system, and all the installed files, their applications and system-wide settings, all they will be stored under these three directories. So for /etc on the Windows side, you can say that system32, program data, registry, these are some of the go-to directories, or somewhat similar directories when it comes to Linux. /lib, this is another directory which will store all the shared library files, containing essential library files which are needed by the applications to run them. So as developers, developers will just develop an application, but the underlying infrastructure which is needed to run those applications on the operating system is provided through library files on a Linux, and is provided through dynamic link library files on a Windows. So all the DLL files that you find on the Windows side and under system32, in the same way in Linux, DLL type of files are library files called lib files often, and you will find them under /lib directory. So under this / which is the root, you will have the lib directory, subdirectory, which is for storing all these library files. On the Windows side, you have these three directories which will handle the DLLs. Windows system32, despite its name, it's the primary directory for Windows system DLLs, including those for both 32-bit and 64-bit versions on 64-bit Windows. So system32 will have both 32-bit DLLs and 64-bit DLLs. If you want to access specifically for 32-bit DLLs, then you need to go for this folder, which is syswow64. This directory will allow 32-bit Windows applications to run on 64-bit Windows. So providing a kind of backward compatibility. Then Windows SX, Windows side-by-side directory, this will help mitigate some DLL issues by storing multiple versions of them under this directory. Then /media /mount MNT, this is also a very important directory because and it is commonly used for mounting external file systems. So under /media, whenever you connect a pen drive or a CD drive, so as we were discussing on the previous slide, if you remember /dev and /sys directory, so whenever you connect any external removable drive or CD-ROM or external media, it gets recognized by the system under /dev. Using the /dev and /sys, the system can interact with that USB drive, and you as an user, if you have to read and write data to that USB drive, to that removable media, you would go to the /media directory, and this is where you will be accessing it. And in modern Linux distributions, the directory, then if you connect a USB drive, it is often created like this /media /username, and then automatically mount removable drives. /mnt is mount. This is traditionally for mounting the network drives when you map a network drive to your server or computer. On the Windows side, you have removable drives and network drives. Removable drives, we all are familiar whenever we connect a pen drive or insert a CD-ROM to a Windows, then Windows will assign randomly a letter to the drive like E or F. There isn't a specific directory like /media, which we see on the Linux side, but this temporary directory is automatically created when we connect some removable media to the Windows server. Network drives and mounted volumes, Windows will allow to mount network drives, so this is pretty much simple. Then /opt, On the Linux side, slash opt is used for installing and storing third-party application software. So if you as an user, if you have downloaded certain application from the internet and if you have installed it on the Linux server, by default it would go into the slash opt most of the times. So slash opt is where you will find your application installed, any third-party application which does not come pre-installed with the server. Any third-party application from the outside, if you're installing, by default it would go most of the times in slash opt. Under Windows, we are very familiar that by default it would go into program files or program files x86. These are the standard directories, standard locations for installing applications in Windows. However, unlike slash opt, these directories don't just hold the third-party applications, but they also hold applications that come pre-installed with the Windows system. So from security point of view, if you think here, Linux is kind of more secure because here the applications that come installed with the Linux operating system, they are stored in different directories, maybe under slash usr bin, sbin, or different directories. And when you install third-party applications, they are segregated under slash opt. But in Windows, unless you are aware and you on your own choose to create a custom directory outside of this, by default it would go into the same folder where you will have both then third-party applications as well as Windows system applications that came pre-installed. Then we have come to slash proc directory. This is a very unique and special directory. It's actually a virtual file system, often referred to as process information pseudo file system. So process information, think of this like a task manager that you see on the Windows side. So this slash proc directory will hold information like process ID, memory usage, CPU usage, all those kind of details about a process, what service, what files it has, that particular process has opened. All that information can be found under slash proc. On the Windows side, task manager, WMI system info tool, registry, all these different things, all these different directories that show you the information about running processes, services, memory usage, all those things, they are all found under slash proc on the Linux side. Then slash srv, this is intended for site-specific data served by the system. This directory will contain data that is served by the system. So if you're using the server as a web server or maybe using it as a file transfer server, so whatever service that you're running on the server for serving to the clients, that specific data will be stored under slash srv. But again, depending on organization needs, policies, and administrator preferences, not necessarily that you will find slash srv is used, but most of the times by default you would find that if it's a web server or file transfer server, that then you will find directories like www under slash srv directory for if it is a web server that is running on the Linux endpoint. On the Windows side, inetpub, program data, custom directories. So we are taking an example again of web server. So if you're running a web server on a Windows, then inetpub under C drive is your go-to folder which will store all the web server content, particularly the web server that is running for iOS. Program data will also contain a lot of information about the application, stored data that is not user specific and very specific to the application. So, and also on the Windows side as well, the choice of location will often depend on the specific service, application requirements, and administrator preferences. But yeah, just take a heads up about the slash srv. We are not doing a very deep dive, but just getting a general understanding of what this directory means and what it will store. Slash temp, a very important directory from the cybersecurity perspective, because slash temp, as the name suggests, is intended for storing temporary files and Very important from cybersecurity perspective to notice is that this directory has write permission for all users on the system, because it has to store temporary data by different processes and different users. So this directory, due to its writable nature for all users, you can understand that this becomes a target for certain types of attacks like symlink attacks, and therefore proper permissions and security measures and monitoring of this directory is very important. um, you know on the Windows side as well, you have temp directory, only the spelling is different. And again, on the Windows side as well, the use of temporary directories in both Linux and Windows is crucial for handling files that are only needed temporarily, and these files don't occupy unnecessary space in the long term. So, and these can be scheduled to clean up on every reboot, or they can be manually cleaned, or some of them are automatically cleaned. I mean, a lot of information gets automatically cleaned when you restart your system from the temp folders, because it is meant for storing temporary information. But from cybersecurity perspective, in both Linux and Windows, you should notice that these directories have writable permissions for all users, and that's why they become target for malware execution, downloading of the malware by the attacker, because the attackers know that slash temp and the temp folder on the Windows side, they have writable permissions, and this can become the attacker's target position for downloading his malware, executing his scripts from these folders. Slash var, again a very important directory from the cybersecurity perspective, because slash var will have this subdirectory known as slash log, which is perhaps one of the most well-known subdirectories. It contains log files that are generated by system and various applications running on it. So from cybersecurity perspective, if you want to monitor a system, collect its logs and make some sense out of it, then, or during a security incident, if you want to monitor logs, then slash var slash log becomes a very important directory for you to monitor. This will also have some other subdirectories. You can read about them later, but yeah, slash var slash log is an important directory here. On the Windows side, you will have mostly event viewer. The log files are stored under system 32 and can be accessed through the event viewer GUI application that Windows provides you, and becomes very important from cybersecurity perspective then to collect these log files. So in case if you're using a SIEM tool and you want to collect logs from these servers, then on the Windows side you should understand that, okay, see Windows system 32 log files, this is the directory that you should configure for collecting logs. And on the Linux side, you can configure slash var slash log to be monitored. Alright, then that's all in this video. If this was helpful for you, if this was genuinely helpful for you, then do like, subscribe and share if you have found this useful. And I hope that this comparison of explaining Linux directories along with Windows on the side has given you a good understanding of how a Linux environment, how the Linux directory structure looks like, and I hope it will help you in your cybersecurity investigations in the future. Alright then, see you in the next one. Thank you.